Welcome to Brain Vision.
Hi, in the given problem, mass of Daniel is given as mt is equal to 65.0 kilogram and mass of Rebecca is given as mr is equal to 45.0 kilogram. Before collision, initial speed of Rebecca was VIR is equal to 13.00 meter per second, and as Daniel was at rest, so his initial speed VID is equal to 0. Now this is their initial direction of motion. Let it be Rebecca, let it be Daniel, then here this is the horizontal line, let it be along x-axis. Then after the collision, Rebecca goes here with the final speed VFD, where VFD is given as 8.00 meter per second, and it is at an angle of 53.1 degree. Suppose this is VFR, Rebecca. Rebecca is going with a final speed of 8 meter per second, and the final speed of Daniel is missing. Let it be VFD, which we have to find, and it is supposed at an angle of theta from the horizontal. So the component, if we find the component of the final speed of Rebecca, this is VFR cos 53.1 degree, and here this is VFR sine 53.1 degree. Similarly, for VFD, for the component of the speed of final speed of Daniel, let it be the speed of Daniel along x-axis, VFDX, we say it, and here this is VFDY, means the component of final speed of Daniel along y-axis. Now, first of all, in the first part of the problem, we have to find the magnitude and direction of the final speed of Daniel, for which we use conservation of linear momentum along x-axis. So it becomes, for Rebecca, this is mr into vir. For Daniel, it is md into vid is equal to, along x-axis for Rebecca, this is mr into vf r cos 53.1 degree, and for Daniel this is md into vfdx. Now plugging in all the known values, for mr this is 45 kg, for vir this is 13 meter per second, but as vid is 0, so this term will become 0. And here after the collision, 45 kilogram for the mass of Rebecca, vfr this is 8 into cosine of 53.1 degree. For Daniel, this is 65 kilogram into VFDX, which is missing. So calculating it, here it comes out to be 65 VFDX, x component of the final speed of Daniel, is equal to 45 into 13, comes out to be 585 minus 216.2, which comes out to be 368.85. So finally, the x component, horizontal component of the final speed of Daniel, here comes out to be 5.68 meter per second. Now we have to find the vertical component along y-axis, for which we use conservation of linear momentum along y-axis, and along y-axis there is no initial speed along y-axis. Before the collision there was nothing along y-axis, so this is 0. And after the collision, for Rebecca this is mr into v f r into sine 53.1 degree, plus for Daniel md into v f d y along y-axis. So plugging in all known values, it comes out to be 45 kilogram into 8 meter per second into sine 53.1 degree plus 65 kilogram into VFD5 here, which is missing. Now, rearranging the terms, it becomes 65 VFDY is equal to minus 287.886, or we can say finally VFDY means the vertical component along x-axis of the final speed of Daniel comes out to be minus 4.43 meter per second here. This negative sign shows that this component of speed is along negative y-axis. Hence, finally, we can find the net speed of Daniel after the collision. So, if we mark it like this is the horizontal component VFDX and this is the vertical component VFDY, then the final speed after the collision for Daniel is this VFD at an angle theta. So to find this VFD, we use vector addition of this VFDX square plus VFDY square. So putting the values of VFDX and VFDY square here, this is 5.68 square plus minus 4.43 square. So here it comes out to be 32.2624 plus 19.6249. On adding, it becomes 51.8873. So finally, this FD comes out to be 7.20 meter per second. Means this is the final speed of Daniel after the collision. Now to find its angle theta, we use tan theta, which is given as VFDY divided by VFDX, and we will use only the magnitude of this VFDY, which is 4.43 meter per second divided by 5.68 meter per second, and here it comes out to be 0.7799. So here it becomes theta is equal to tan inverse 0.7799. So finally theta is equal to 37.95 degree, or we can say this is 38 degree. So this is the final velocity of Daniel after the collision, having a magnitude of 7.20 meter per second and at an angle of 38 degree from the original direction. Now, in the second part of the problem, we have to find the change in kinetic energy of the system, and that will be given as the final kinetic energy of both the Daniel and the Rebecca. So for the kinetic energy of Daniel, this is half mg into VFD square, plus for the kinetic energy of Rebecca, this is half mRVFR square. Then minus initial kinetic energy half md VID square plus half mRVIR square. Now we take this half as a common out and putting all other values. For MD, this is 65 kg, 7.20 square plus 45, 8 square minus as VID is 0, so just VIR will give us 45 into 13 square. So finally it comes out to be half into 3369.6 plus 2880 minus 7605 joules. So here it becomes minus 677.7 joules, or we can say approximately this is minus 678 joules. So this is the loss in kinetic energy of the system. Thank you.